Today we're going to talk about simplifying radicals and nth roots today. We'll do multiplication, division, talk about addition, subtraction later. A square root is actually a second root, right? When you do a square root, like if we say what's the square root of 16, we're asking the question, what number times itself gets you 16? And 4 times itself gets you 16, so the square root of 16 is 4. Well, you could do a third root. Like if we asked for the third root of 125, that's really asking the question, what number times itself 3 times, I won't put equals to, but what number times itself 3 times gets me 125? Well, that number is 5. So the third root of 125 is 5. And there's fourth roots and fifth roots and a millionth roots and whatever types of roots you want to do. So like for the fourth root of 16 is 2, because 2 to the fourth is 16. And the fifth root of 243 is 3, because 3 to the fifth is 243. So whatever this number is called your index, that number sitting on that little shelf, I call it the root shelf, but it's really the term as the index. Whatever your index is, that's how many times you're multiplying a number to get to this. Let me show you how to do that in your calculator real quick. I'm going to do the fifth root of 243. If I just press the number 5, then I press this math button here, I can go down to xth root. So for the record, that's a third root. If you want to do a cube root, it's right there. But there's the xth root. Now I can do any root. So this means fifth root, because that little 5 is going in place of that x. So the fifth root of 243 is 3. So now you can calculate any root if you want that way. I want to make something really clear. When you're doing square roots or fourth roots or sixth roots or any even root, you only do the plus or minus if you're solving. So like here's the equation, x squared equals 25. Well, to solve this equation, you'd take a square root of both sides and get that x equals plus or minus 5. There's 2 solutions. There's 2 things that work. Both 5 and negative 5 get you to 25. But if you don't have to solve, if you're just calculating, like if you just have this, the answer to this question is not plus or minus 6. This is literally asking, what is the square root of 36? And the square root of 36 is just 6. I could ask for the negative. The negative square root of 49 is negative 7. But that's because I'm just doing the square root of 49 and then making it negative. Here I was solving. Solving means find every single thing that could possibly work. But here we're just calculating something. Find the positive square root of 36, and that's 6. Or find the negative square root of 49, and that's negative 7. So please don't confuse those things. If you're not solving, there's not 2 solutions. Okay, you've done simplifying radicals before. It's often done with a factor tree. So what I'm going to do is pull out all the factors of 252. This is review even from this year at this point. 252 can break down into 2 and 126, which is 2 and 63, which is 9 and 7, and then 3 and 3. And at this point, I'm looking for pairs of numbers that are the same number. So like 2 2s can come out, and 2 3s can come out, but 7 stays behind. Pairs come out, and they multiply. Things that don't have pairs, meaning the exact same number to match up with, stays behind. So right now I have 6 root 7. The square root of 252 is the same as the square root of 6 root 7. And you can check that. I'll do the square root of 252. And I'll do 6 root 7. Did the same thing. I've also got to deal with this x, though. I've got to see how many pairs of x's can I pull out. Well, x to the 6 really is 3 pairs of x squareds. So it's like here I pulled out a pair, and here I pulled out a pair. Well, now I can pull out 1, 2, 3 pairs. So it's this. 6x to the third root 7. One way to think about that is you just take this power and divide it by the number on that shelf, which in this case was a 2. What might be a little bit new for some of us is doing third roots. Well, 120 is 40 and 3, 40 is 2 and 20, 2 and 10, 5 and 2. You can break this down in any order you want. It doesn't matter. You'll always end up with 2, 2, 2, 3, 5. This really means that 120 equals 2 times 2 times 2 times 3 times 5. Well, because this is a third root, I'm no longer looking for pairs. I'm looking for triples. I want to find groups of 3, not groups of 2, but groups of 3 that I can pull out. So here's a triple that comes out. but this little 5 has nobody, and this little 3 has nobody, so they stay behind. 3 times 5 is 15. Now I'm checking how many groups of 3 can I make out of 17. There's 3, 6, 9, 12, 15 groups of 3 with 2 left over. With this, there's 1, 2, 3, 4, 5 x's that come out. 5 groups of 3, x to the 5th, with an x squared left behind. And there's my simplification. Now this process seems really weird. It's actually quite simple though. I can just take this power and divide it by this number and think about remainders. 17 divided by 3 is 5 remainder 2. Don't do a decimal, it's 5 remainder 2. So there's my 5, and there's my remainder 2. I have another video with tons of examples of all these problems, actually. Like 20 minutes worth of examples of problems that I'm not going to put here because I want you to have the option of just watching this video or going to another one and seeing all the examples, but you can find it and I'll link it. We've got 2 more slides. This one is about rational exponents. We have a power that is a fraction. X to the 1/2 is actually the same as the square root of x. And it makes perfect sense if you think about it. Say that x to the 1/2 equals 3, and I want to find what x is. Well, one way to do that would be to get rid of this power. And to get rid of this power, I would take both sides to the second. Because when I take both sides to the second, 2 times 1/2 becomes 1. Those things cancel each other, because 1/2 and 2 as powers are inverses. So you'd get that x equals 9. Well, if x to the 1/2 equals 3, and x equals 9, that means that the square root of x is 3. So the square root of x is the same as x to the 1/2. In the same way, 8 to the 1/3 is really the third root of 8, which is 2. 8 to the 1/3, always do those powers in parentheses like that. 8 to the 1/3 is 2, or I could just do the third root of 8, which is 2. They're the same thing. So 8 to the 1/3 is the same thing as the third root of 8. And now what can get a little bit more confusing is if the powers are fractions that don't have a 1 in their denominator, or that's the numerator, excuse me, the numerator. This is really negative 125 squared in a third root. It's the third root of negative 125 squared. Because you can think about it like it's negative 125 to the 1/3 squared. Or other order, negative 125 squared to the 1/3. However you want to think about it. So I could find the third root of negative 125, which is negative 5, and then square that and get 25. This comes out to 25, which again, you can just calculate. In parentheses, I'll do negative 125 to the 2/3. It's 25. And if you wanted to get real dirty, you could do like 16 to the negative 3/4. Ugh. But you'll see this. You have to deal with this. 16 to the negative 3/4. A negative power flips a fraction over. It's 1 over 16 to the 3/4. That's what the negative power does. Flips a fraction over. And then that's really 1 over the 4th root of 16 to the 3rd. And I would do the 4th root of 16 first. Make the numbers smaller before you make them bigger. The 4th root of 16 is 2, and 2 to the 3rd is 8. It's really 1 over 8. And that might seem like just totally, completely confusing, but once you spend some time with it and get some practice and think it through, it'll be pretty straightforward. The last thing to deal with is simplifying with multiplying or dividing. Pretty straightforward, actually. With multiplication, you just multiply the stuff inside the radicals. And if there was stuff outside the radicals, I'd multiply them also. So say that I was multiplying these two things together. 3 root 24x to the 6 times 4 root 18x to the 3rd. Well, I would do 3 times 4 is 12. 24 times 18 is something pretty big that I'll just calculate. Oh, come on, don't break. You're going to break. 432. And x to the third times x to the sixth is x to the ninth. You just add those powers. Well, now I'm going to break down the 432. I know it multiplies into 24 and 18. I mean, I just did that. So I know it multiplies to 24 and 18. So the first step of breaking down shouldn't be that hard. 24 is 4 and 6. 4 is 2 and 2. 6 is 2 and 3. 18 is 9 and 2. 9 is 3 and 3. Because I'm doing a square root, I'm looking for pairs of the same number. Well, there's a pair. There's a pair. There's a pair. I just look at the ends of the trees, so these numbers here don't matter at all. So I can pull out a pair of 2s, another pair of 2s, and a pair of 3s, and what's left behind is this 3 right here. But there was already a 12 on the outside. Don't forget that 12 was already there. So right now we have this. So 2, 4, 12, 144, root 3x to the ninth. Now I got to deal with the x's. 9 over 2 is 4 remainder 1. So 4 will come out, and 1 stays behind. And whew, that might not seem any simpler, but it actually is. This is actually going to be much easier to work with than this was. That's how you multiply radicals. Division is a kind of different beast. I'll actually move that. I won't erase it. You can take this and split this up into 2 separate things. And there's this annoying rule in math that I'm not sure is going to stick around forever, but it still lasts right now, but it might change, where we don't like having radicals in the bottoms of fractions. The reason I think it might change is because with calculators it doesn't matter so much anymore, but there are some times where it does, like in trig and other simplifying things. But anyways, the rule is you can't have radicals in bottoms of fractions. So we have to get rid of that. This right now is the third root of 3. If I were to multiply that by the third root of 3 squared, now this is kind of tough logic, so track with me. Right now there's 1 3 in there. I want there to be 3 3's in there, so when I do the third root it's really easy. The third root of 3 to the third is just 3, because the power and the radical cancel each other. So I want to take this 3 to the first and make it a 3 to the third. So I do this. I multiply by 1. I multiply by the same thing on top and bottom. I'm really multiplying by this big old 1. And that allows me to get on top the third root of 9 times 20 is 180. And on bottom I'll just have 3. Because this is really the third root of 3 to the third, which is just 3. Now I'll simplify. 180, can that break down at all? I know it's 20 and 9, which is 4 and 5, which is 2 and 2, and 3 and 3. And since I'm doing a third root, there's no pairs. Or sorry, no triples. So nothing can come out of this. If stuff could come out, then I'd pull stuff out and maybe factor and do more stuff from there. But nothing can come out, so this is my simplified form. If I wanted to check that in my calculator, I could. You can't have a radical on the bottom, so you multiply by something on the bottom to get rid of the radical. If I had this, I'll just make up a quick one real quick. Then I would multiply by the 5th root of 4 to the third. Because that makes this 4 to the 5th. And then 4 to the 5th cancels with the 5th root of that. So the 5th root of 4 to the 5th is just 4. So the idea is you make this power here match this power here with whatever it takes. Whatever it takes to make those two powers match. This one over here looks miserable. It's actually not that bad. If we had this, we would just subtract. So here, we're just going to subtract. I'm going to do 2/3 minus 3/4. And sure, those need a common denominator, 12. And you get x to the negative 1 over 12. It could be 1 over x to the 1/12. So I'm going to make some room here. One over x to the 1/12. It's the same as 1 over the 12th root of x. And remember, I can't have radicals in the bottoms of fractions, so I'm going to multiply by the 12th root of x to the 11th. And that gets me this pretty obnoxious looking thing, the 12th root of x to the 11th over x. Which I also could just leave like this. That's also fine. Okay, like I said, there's a video with lots of examples if you want to watch it, but we're going to call this good here.